Hello, my shimmering stars. Today, I, Shaurya Grover, welcome you all to this amazing platform of PW English. So, students, I welcome you all to your Nexus Batch, and today we are going to start with a new chapter that is chemical bonding. So, students, I hope so. You have seen the previous lecture, the previous chapter, and it was quite clear to you all. Now, today we are going to proceed to a new beginning that is going to be chemical bonding. And let me tell you, this is going to be the most interesting chapter of yours of class 11th standard. So before starting the students, I have few lines for you. Please listen to it very carefully. The greatest glory in living lies not in never falling. The greatest glory in living lies not in never falling, but in rising every time we fall. So students, whensoever you feel in life that yes, it is the hardest phase or you're not able to do anything, just remember that this is the phase where you have to stand up again and then you have to move further. And when you'll move further with that confidence that yes, no matter what has happened, no matter I'm not getting the topic, no matter, it is the hardest time, but I am, not giving up and standing and moving further, that phase of your life will make you the most, stronger person that you can ever imagine. So you will become more stronger than before. Yes, students. So with that, we are going to start with our new chapter. So I guess each and everybody of you are ready. Now what you have to do, as if, in this particular session, in this particular chapter, we are going to understand chemical bonding with, animations, with videos, such as where overlapping is seen, how hybridization takes place, how do the structure look alike. So we are going to do all of that in detail with the help of animations, 3D animations, okay? And I guess this will be the most interesting one. So students, before starting this, let me tell you what are the topics we are going to cover today in this particular session of ours. See, today's session is based upon the general introduction to the chapter chemical bonding, as well as this session is particularly based upon modes of chemical bonding. Moreover, we are going to cover the previous year questions of the chapter classification of elements and periodic properties. As I've told you in the previous class that yes, we will be solving previous year questions, we will be doing your homework questions, okay, and we will be also covering the new chapter. So I guess you all are ready. Take your notebook, take a water bottle, stay hydrated. Yes, students. Now let us start this session with a beautiful smile. So ma'am, as you all very well know, this is going to be your which lecture? Lecture number first. On which chapter? Chemical bonding. As well as we are going to practice some PYQs, that means the previous year questions that are asked in your competitive examination for the chapter periodic classification or classification of elements and the periodic properties. Okay, students. So, the very first thing is, first of all, the very first initial topic is going to be introduction to chemical bonding. The second part is going to be modes of bonding. The third segment will be about discussion of the homework questions. And the fourth segment will be based upon previous year questions and, of the classification of elements and the periodic properties. So now we are going to start with our very first topic. But before that, we have your friends with you, calcium and barium, waiting for you all students. So as I'm saying calcium and barium, I just remember that yes, we have given you so many tricks in order to remember the periodic table. So have you revised that tricks? If not, students, don't miss that tricks topic. Go and learn the periodic table, because again and again, you will be seeing that in the variation segment in the previous chapter, we had a variation topic, variation in across the period, along the group. So over there, if you know the periodic table, it will be easy for you. But if you don't know the periodic table, no, it will create a a little bit of confusion, a little bit of time consuming concept will be there, because if you don't remember it, you will waste your time. So it's better go learn with the help of tricks the whole periodic table. And sometimes what happens, you're learning but you're not remembering. Yeah, so what you can do is open up your questions, start solving your questions, practice more and more questions, and then apply the trick over there. See, this is also another way to learn key concepts. Yes? Okay. Now, barium and calcium are welcoming you over here. So, calcium says, hello, shimmering stars. Have you revised yesterday's class? See, she's so much concerned for your previous sessions. Yeah. In each and every session, she's there and then she asks you that whether you have revised or not. So, don't disappoint her. Don't disappoint me. Don't disappoint yourself. Yes. Do revise each and every session, then only you can succeed in your life. Everybody knows the topic, everybody understands the topic, but the concept is they don't revise it, okay, and they lack over there, and due to this they forget an examination. See, exam pressure is another, fear, right? In order to conquer it, in order to come out of it, you have to do a lot of revision. Without revision, you cannot be successful. So she is there, in each session to make you remember this, that you have to revise. Now here barium says, hi friends, be ready for the new chapter. Yes, okay. So starting with the very first topic of ours, that is going to be introduction to chemical bonding. Now my very first question is, what is the chemical bond, students? What do you feel is a chemical bond? See, chemical word somewhat says about chemical reactions, ma'am. And bond is something where there is some kind of attraction or there is a line in between two atoms. Sorry, a line between two atoms is a bond, or a thread between two atoms is a bond, or what is a bond, ma'am? But ma'am, in books we have seen, for example, if it is written A and B have a single line in between, that is bond. No, students. Thread is not a bond. Line is not a bond. What is a bond? Bond is basically the attraction between two atoms. Sort of bonding between two atoms. Now, what kind of bonding between atoms? What kind of attraction between atoms? We are going to understand them. We are going to understand it. Now, attraction can be like one positive and negative are attracted towards each other. That attraction in other terms is a bond. That sharing of electrons in other terms is a bond. That donating electrons and creating a bond, donating, one atom is donating electrons and creating a bond, right? That is a bond. So bond is not a thread, bond is not a line, bond is basically sharing and making, a complete molecule which has the octet complete, a configuration complete. So let us understand chemical bonding in detail. Now you very well know what is chemical. Chemical is something related with chemical reactions. Bond is something whereas there is attraction, there is sharing. We are going to understand it. There is transferring of electrons. So this is kind of bonds that we are going to observe. Yeah. So, ma'am, if we'll talk in general, is there, we are going to understand about types of bond over here. We are going to do that one by one. So, as I've already told you that from the word chemical bond, what comes in your mind? A thread, a bond, attraction. So, what is a chemical bond? Chemical bond basically the attractive force which holds various constituents. Now, the constituents over here can be atoms, can be ions, basically the particles. Together in different chemical species is called a chemical bond. So this is a simple definition that the attractive force which brings two atoms all together is a chemical bond. Quite simple. Quite simple. If something is positive in nature and if something is negative in nature, they are coming together, they are sharing their electrons or they are attracting towards each other. That is the bond formation. The attractive forces between the constituent particles which leads to a formation of a particular molecule, a particular structure, a particular compound is a chemical bond. Yes, everybody. Now, students, there are so many questions that comes in your minds. For example, why do atoms combine? This is a question which generally comes in students' mind. Ma'am, why they are combining? What is the need to combine? If they won't combine, then we are not going to study anything. No, this is the joke. Jokes apart. Why do atoms combine? What is the reason behind them, ma'am? In order to attain stability, in order to exist in a certain phase, yeah, in order to complete its octet. There are many reasons, yeah. So we are going to do that in this particular chapter. Now, what question is the next question that comes in your mind? The next question is, why are only certain combinations possible? Why only certain combinations are possible? Not, there are some compounds, there are some elements which don't, form bonds. They don't react. Why is it so? What is the reason behind it? Next question that comes to your mind is, why do some atoms combine while certain others don't? What is the reason? Why not all the elements? Why not all the elements? Another question comes to your mind, why do molecule possesses definite shape? What is the reason? Why do we calculate hybridization? All of these key concepts will be explained in this particular chapter with the help of Lewis dot structure, Lewis theory, with the help of Vasper theory, with the help of valence bond theory, hybridization, molecular orbital theory. These all topics will help you to attain the answers for this particular questions. Clear, everybody? So now this was the introduction basically, and these were, yes, the NCERT highlight as well. Now, starting with the very first part over here, what is the chemical bond? Now, before this, the types of bonds, let us understand about the modes of chemical bonding. How does chemical bonding takes place? How does chemical bonding takes place? So, chemical bonding takes place by two ways. Chemical bonding takes place by two ways. The very first way, the A way, is by sharing of electron. No, first of all, right, first by transferring of electrons. The very first way is by transferring of electrons. So by transferring of electrons, you can see that yes, there is a chemical bond being formed. Now, by transferring of electron, which kind of bond is being formed? By transferring of electron, you see ionic bond is being formed. Which kind of bond, ma'am? Ionic bond is obtained. Okay. Okay. What is the next way? Another way? By sharing of electrons. By sharing of electrons. So by transferring of electrons, you create a chemical bond such as ionic bond. By sharing of electrons also, you create a bond. Now by sharing, how do you create a bond? Which kind of bonds? Over here, now you can obtain two kinds of bonds. The very first that you will obtain will be your covalent bond, and the another one will be your coordinate bond. Another one will be your coordinate bonds. So three kinds of bond we are now going to focus upon, that is ionic bond, covalent bond, coordinate bond. Coordinate bond in other terms is dative bonds also. Now what are these? See, a hint I have already provided you that when you transfer electrons, you are going to obtain ionic bond. When you are sharing the electrons, you are going to obtain either the covalent or the coordinate one. Now we will understand them one by one. Let us start with the very first kind of bond, that is going to be your ionic bond. That is going to be your ionic bond. See, if I'll talk about ionic bond is seen in the case of cations and anions. Cations are the one which has positive charge. Anions are the ones which have negative charge. Yes. Now see, in the case of ionic bond, I already told you cations and anions formation occurs. Let us take a general example. See, this is just an introductory section, okay? In the next lecture, you are going to start with the very first topic and then you're going to understand. But in today's session, you will understand what is chemical bonding, why do chemical bonding takes place, what is the cause behind them, how does it occur. So basic key concepts we are going to clear one by one. If you have not read anywhere, if you're starting from the very first time, it will be very, very helpful for you. Coming back over here, let us take an example of NaCl. How is NaCl formed? So we are going to understand about formation of NaCl. Now see, NaCl contains two types of, ions. NaCl contains two types of ions. One is Na positive, another one is Cl negative. Na positive, Cl negative. Na positive is your cation, Cl negative is your anion. So step by step we are going to understand them. First of all, I want you all to write each and every line which I have written over here so that I can move on to the next part. Shall I move on to the next part? Shall I move on to the next part? Yes, ma'am. Okay. So see students, now is the very first step is formation of cation. Formation of cation. Now understand. In the formation of cations, that means the positively charged particles, that means what happens? See, we know sodium, Na. It has an atomic number 11. So what will be the configuration? Ma'am, 1s2, 2s2, 2p6, 3s1. Now see, how will this Na become stable? Na can become stable by losing one electron. Why I am saying that? See, if I have to fill all the electrons, 1s2, that means 2 electrons, 2s2, again it is 2 electrons, 2p6, so it is 1, 2, 3, 4, 5 and 6. Again it is completely filled. Now it is 3s1. Only one electron. See, only one electron. So if we are going to lose this one electron, it will attain a stable configuration which has, paired electrons, completely filled orbitals. So by losing one electron, it becomes stable. By losing one electron, it becomes stable. Yes. So what it will do? Na will lose one electron and will form what? It will form Na positive. What happens over here? Na will lose one electron and will form Na positive. When it will lose one electron, it will have a configuration of 1s2, 2s2, 2p6, which is stable. So here, this is the formation of cation Na positive. Now, why there is a positive charge if it is losing an electron? For example, I am a neutral species. Neutral species is something which has equal positive, equal negative. Clear? If I am losing negative, I will be positive. Simple, no? If I have equal positive and negative, I am neutral, I have no charge. If negative goes, I will be left with positive. So it becomes Na positive. The next step. The second step. Second step is formation of anion. Formation of anion. Now see, what happens? Now let us talk about chlorine. Chlorine has what atomic number, students? Ma'am, chlorine has 17. So we are going to write it. See, if we are going to write the electronic configuration for this as well, it is going to be 1, S2, S2, 2, P6, 3, S2. See, electrons. 2 plus 2, 4. 4 plus 6, 10, 12. 5 are left. 3p5. Yes, everybody, 3p5. So if we are going to fill electrons, it is 1s2, 2s2, 2p6. So 1, 2, 3, 4, 5, 6. 3s2 and 3p5. So 1, 2, 3, 4 and 5. It requires one more electron to become stable. It loses and becomes stable. It requires one electron to become stable. So, by gaining one electron, it will become stable. By gaining one electron, it will become stable. So, what it will do? Cl will gain which electron? The electron being lost by Na. It will gain that electron which is loosed by Na, which is provided by Na. So now this electron is gained by chlorine and it will form what? Cl negative. How Cl negative is seen? See, when you are gaining one electron carries a negative charge. Electron carries which charge? A negative charge. So what it will become? It will become Cl negative, because if something is acquiring which kind of charge? Something is acquiring a negative charge. Now see students over here. For example, I am a neutral species. I have positive and negative. If negative is coming to me, more negative is coming to me, I will become more negative. If positive is more coming to me, I will become more positive. Electron carries a negative charge. So negative when comes, it will gather a negative charge on it. Now see what happens. Now what we have formed till now? We have acquired Na positive, we have formed Cl negative, right? So now when this Na positive and Cl negative combines with each other, they are going to form NaCl. They are going to form they are going to form NaCl. Now let us see with the help of Lewis dot structure also. No need to worry, Lewis dot structure I will explain you in the next class how to write it, how to draw it, but understand key concept. Now Na positive, let us take an example. That means Na here has donated its electrons to chlorine to form this. Let us see with the help of Lewis representation also. See, Na basically has how many valence electrons? Valence electrons is the outermost shell electron. It is 1 over here. So you will represent only 1 electron. That means it carries one, it has only 1 electron in the outermost shell. Now see, here is chlorine, and chlorine basically has how many electrons in the outermost shell? Outermost shell is third shell. 2 electrons of S and 5 of P. That means 7 electrons. Here it has third shell outermost but only 1 electron. Here it has 7 electrons. So it is going to be 1, 2, 3, 4, 5, 6 and 7. 7 electrons. Now what happens? We have just now seen that Na will donate its 1 electron to Cl and will form what? It will form NaCl. So Lewis dot representation we will understand in depth in the next class when we are going to understand about the Lewis theory. But over here I am telling you, here ionic bond is seen. What is seen to you? Here which kind of bond exists? Ionic bond exists between what? Between cations and anions, ma'am. That means between Na positive and Cl negative, ma'am. So over here, what is happening? Over here, there is transferring of, electron that is taking place, right? So here you can even mention over here, there is transferring of electron that is taking place. Clear everyone? Write down the very first case of transferring of electron. This is an example of transferring of an electron. Clear everybody? Clear everybody? That is formation of NaCl. In actual students, if I show you the 3D structure of NaCl, how does it looks like? So see over here. For example, this is your Na, okay? It is surrounded by 6 chlorine. How in such a way? See, 1 chlorine will be here, 1 chlorine will be here, 1 will be here, 1 will be here, 1 at its back and 1 at its front. So this is back and front, which I have represented by dotted line. So NaCl structure, the rock salt like structure, you are going to observe in solid state chapter also in depth, right? Clear everyone? Everybody please write it down so that I can start with now the sharing of electrons. This was the transferring of electrons. Now comes the sharing of electrons. The next is by sharing of electrons. Now see, elements, they not only transfer electrons, they can also share the electrons in order to become stable. Now they became stable because their electronic configuration were fulfilled. They can also become stable but by sharing of electrons. Let us take an example. First I am taking a case of your covalent bond of your Covalent bond. So in the case of covalent bond, I'm taking an example of CH4. Now students, you very well know about carbon. Carbon basically is atomic number 6. So it is 1s2, 2s2, 2p2. Yes, it is 1s2, 2s2, 2p2. It is combining with 4 hydrogen atoms. Though you will understand in the upcoming segment that what are hybrid orbitals, how does hybridization takes place. But in general, I'm just discussing it normally. Carbon basically, let me tell you one thing over here, because for now you will think that only 2 electrons are there, that 2 orbitals are empty, so 2 bonds will be formed. No, you will get to know about the hybridized orbital. But yes, you can understand in this way, that the valency of carbon is 4. Valency of carbon is 4. Now ma'am, what is valency? In the previous session, if you remember, I've already told you the definition for valency. Ma'am, what was the definition for valency? Right? So valency, students, was basically the combining capacity of element. What it was? It was basically the combining capacity of any element. That means it can combine with 4 elements. That means with 4 hydrogens. Now let us consider, for example, we have this carbon. Carbon has valency 4. That means 4 are the electrons that are seen in the outermost shell, because see, 2 is the outermost shell. It contains 2 electrons of S and 2 of P. That means 4 electrons, represented 4. Now let us talk about hydrogen. See students, hydrogen basically atomic number 1, so it is 1s1. So 1 electron in the outermost shell. So it is combining with 4 hydrogens, and each hydrogen contains one electron in the outermost shell. One electron in the outermost shell. So now see, hydrogen, when it will gain 1 electron, it will complete its duplet. Duplet is holding 2 electrons. S orbital can maximum hold 2 electrons only. So it will gather this electron. See, it is creating a bond by sharing this electrons. See, that's why I put in a circle. 2 electrons, stable. It is sharing its electrons, stable. Sharing its electrons, stable. Sharing its electrons, stable. Now let us talk about carbon. Carbon is having 4 electrons. Now it is also sharing this and this. So 1, 2, 3, 4, 5, 6, 7, 8. That means 8 electrons. That means its octet is now complete. So over here, what are you observing? Here, if we'll see, here we will see that it is sharing of electrons. It is what, ma'am? It is sharing of electrons in order to attain stability. In order to attain stability. Now that can be attained in the way of getting an octet complete or the duplet complete. Octet complete or getting the duplet complete. This can be done in such a way. So now in short, you know why chemical bond is created: in order to complete the octet, in order to attain the electronic configuration, in order to become stable. Quite clear? This was about the covalent bond. Covalent bond in other terms is sharing of electrons. In other terms is sharing of electrons. Ma'am, now comes the second type, that is coordinate bond. Now comes the second type, that is coordinate bond. See students, coordinate bond is also referred to as dative bond. Now understand, in covalent bond, 2 atoms are sharing their electrons with each other and creating a bond. But in covalent bond, one single atom is sharing its electrons and creating a bond. In this, 2 atoms are sharing the electrons and creating a bond, but in coordinate, only one atom is donating electrons and sharing electrons. So in coordinate, only one atom is sharing its electrons and creates a bond. For example, if A has electrons and B doesn't have electrons, so A will share the electrons with B. So when it is sharing, arrow will be made in such a way. That means A is sharing and A holds electrons. B does not have electrons. A is sharing its electrons with B. Clear everybody? Also in covalent bond, it arises due to difference in electronegativity. one thing more you can add over here, difference in electronegativity. Now you have already understood about the term electronegativity in the previous class, that is tendency to attract shared pair of electron towards itself. For coordinate bond in depth we will understand in the upcoming classes, but yes, this is a quick review of what is a coordinate bond. Clear everyone? Everybody please write it down. Everybody please mention it, write it. Done. That's great, students. That's really, really very good. Now, in short, if I have to say, chemical bond is categorized into, now this is classification. Classification is done as ionic, covalent, and also metallic bonding. See, metallic bonding, let me tell you, it occurs between what? It occurs between kernels and free electrons. Now this we will understand in depth in the upcoming classes, but yes, you should know it occurs between kernels and the free electrons. Now also metallic bonding is also categorized into hydrogen bond and the van der Waals bond. Hydrogen bond and the van der Waals force bond basically are intermolecular bonds. Okay, and the other one, ionic bond, covalent bond, metallic, they were interatomic bond. When the bonds are seen between atoms, that are interatomic. When the bonds are seen between molecules, that is the intermolecular ones. Yeah. So one by one we will understand them, but yes, in the upcoming sessions, right? So students, now comes, this ends our, the very first segment of ours, that was discussion with regard to the chapter chemical bonding. Now we are coming to your chapter, that is classification of elements and periodic properties. So as I've already told you, we are going to discuss the homework questions, the most asked homework questions. As there, you may observe that one or two questions are not in the homework, which I have not discussed over here, because I have not seen any kind of doubt over there. They were very simple questions. So the questions which I felt, yes, you are facing an issue, you know, 90% homework questions are being solved over here. If one or two questions are left, if you are not able to do so, you can ask in the chat section as well. So starting with homework questions, we will be doing NCERT in-text questions, and then we will be doing the homework question and then the previous year questions. So let us start with the very first question of yours, that is problem number 3.1, that is NCERT in-text question. Now from here, from this particular page, we are going to start with your homework discussion. This is your homework discussion for your chapter, that is classification of elements, that is classification of elements and periodic properties. Clear? So the very first homework question is written in front of you. Let us read it. That is problem 3.1. It says, what would be the IUPAC name and the symbol for the element with atomic number 120? 120. 120. For 1, it is written as un. For 1, you write un. For 2, you will write bi. For 0, you will write what? Yes, I've already told you that what you have to write. For 0, you are going to write nil, everybody. For 0, you will be writing what, ma'am? Nil. Yes. For 1, it is un. For 2, it is bi. For 3, it is tri. In such way, right? For 0, it is nil. And at the last, you have to write ium. So what it will be, ma'am? It will be un, bi, nil, ium. So ma'am, this is the name for 120 atomic number. And what are the symbols? The initial letters UBN. So it is UBN. This is the symbol. Everybody write this homework question down so that we can move on to the next part. Done with this? Yes, everybody. Done, 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 done. That's great. Next question comes now. Problem 3.3. The element Z is equals to 117 and 120 have not been discovered yet. In which family group would you place these elements, and also give the electronic configuration in each case? So it's very simple, students. If I'll talk about the group number 117, it belongs to your halogen family. To which family, ma'am? To halogen family. So it will have the same electronic configuration of the halogen family, that is going to be NS2NP7. Sorry. NS2NP5. That means 7 electrons in the outermost shell. So this will have the same electronic configuration as this. And over here, if you will see in the halogen family, fluorine, chlorine, bromine, iodine, all of that stuff, 117th lies in the period number 7th. So the outermost electronic configuration is going to be 7s2, 7p5. Clear everyone? Write it down students fast so that I can now move on to your 120 element. Okay, so family we have already told it is halogen family. Group also they're asking it is group number 17. Then our next part is about 120. See, 120 basically lies under alkaline earth metals. And if I'll talk about the group, that is going to be your group number 2. And if I'll talk about the configuration, it will have NS2. 7s2. Clear? Outermost configuration. Clear everyone? Moving on to the next question we have. Problem 3.4. Considering the atomic number and the position in the periodic table, arrange the following elements in the increasing order of metallic character. Which order? Metallic character. Right? We have been provided with silicon, beryllium, magnesium, sodium and phosphorus. Yes, everybody. Yes, everyone. See, sodium lies over here, magnesium over here. Okay, and I'm just writing the order, students, okay, in order to make you understand. Then we have, it is like this, no? Beryllium, magnesium, sodium, magnesium over here, and then we are left with potassium and silicon. Yes? Sorry, phosphorus and silicon, not potassium. So first of all, there is no need to write lithium. Lithium I've written for the beryllium sake. Okay. Yeah. So we require only sodium over here. Yeah. So this is going to be group number 2nd. Now we require which element? I'm going to put tick over here. We require beryllium. We require sodium. We require magnesium. Right? Yeah. Among group 1 and group 2, these are the elements. Now we have to tell the metallic order, students. So what will be the order as per the group, students? What do you feel what is going to be the order? Anybody just think about it. Just think when you're moving across the group and along the period. See, very simple thing if I have to tell you, when I'm moving from top to bottom, no, metallic character will increase. And when I'm moving from across a period, metallic character decreases and non-metallic character increases. Okay, let us talk about sulfur and silicon over here. Not sulfur and silicon, phosphorus and silicon. Again and again it comes out to other words. Yeah. So phosphorus belongs to which family? Nitrogen family. Yeah. Nitrogen, phosphorus. And if I'll talk about your oxygen over here, oxygen, then we have silicon. Yeah. No, it silicon or oxygen, sulfur, selenium, tellurium, polonium. And if I'll talk about carbon over here, for carbon we have carbon, then silicon. Yes, silicon, germanium, in such a way. So here we require not carbon, not silicon, not oxygen, not sulfur, not selenium. In this way. This is the order now. See, when you're moving from top to bottom, metallic character increase. I am deleting other elements. I am deleting all the other elements. Yeah. See, now we have this trend over here. Here, see, metallic character decreases. That means this is going to be the order. And from top to bottom, it increases. So this is going to be the order. Yeah. So this is going to be the order. We have total 5 elements. This is going to be the order. The highest one will be of whom, ma'am? The highest one will be of sodium. Then it will have of whom, ma'am? Then it will have of magnesium. After that, what we will have? We will have beryllium and then we will have silicon and at last it will be phosphorus. So it is sodium, magnesium, beryllium, silicon and phosphorus. If you want to write, it belongs to your carbon family. That means your group number 14th. It belongs to your 15th group. Clear? And if it belongs to your group number 2nd, it belongs to group number 1st. By this way, you can write it down. So clear, students? Shall I move on to the next one? Dun 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 dun. Great. Now, in terms of period and group, where would you locate the element with Z is equals to 114? Now, I guess this back exercise question we have already discussed in the class. Yeah, this we have already done with 114. Now comes the questions which I have given you as a homework. In the long form of periodic table, all the non-metals are placed under. The very first is S block, P block, D block, F block. So very simple. All the non-metals are placed under the P block family. Now only we have seen that when we are moving across a period, that means from left hand side to the right hand side, ma'am, metallic character is going to decrease. That means non-metallic character will increase. So that means all the non-metals are placed under the right hand side of the periodic table, that is P block elements. Hence answer comes out to be option number B. Clear everyone? Shall I move on to the next question? Everybody write it down. Everybody write it down so that I can start with my next question now. Done, students? Okay, here comes your next question, which is a metalloid? PB, SB, Bi, and Zn. So students, quite easy. Option number B is the right answer. What is the metalloid? Which holds the properties of metals as well as non-metals. Clear? Simple question. Moving on to the next one. The element with atomic number 55 belongs to which block? S block, P block, D block, F block. So either write the configuration or not. If you know the, let us talk about group number 1. See, it has atomic number 1. Now you have to use the magic trick: 2, 8, 8, 18, 18, 32. So add 2 into 1, you will get 3. Add 8 into 3, you will get 11. Add again 8, you will get 19. Add now 18 into it, you will get what? 37. Now add again 18, you will get what? 55. So cesium basically is the element which has atomic number 55 and it belongs under the S block element. So the answer comes out to be option number A, as it is cesium. Clear, everybody? Write it down so that I can move on to the next question of ours. Done, students? That's great. Now students come, which of the following alkali metals has smallest size? Now alkali metals, what are alkali metals? It is basically hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. So see, when you're moving from top to bottom in a group, what happens, ma'am? Number of shells increases. If number of shells are increasing, atomic size will also increase. Ma'am, if atomic size is increasing, so this is going to be the order. So the least one will be hydrogen. Is hydrogen there? No. Lithium there? No. Then we have sodium. So answer here comes out to be option number C. Answer here comes out to be option number C. Clear, everyone? Smallest size. Clear? Let us see the next question now. Which of the following ionic species has largest size? Now this is the different kind of question. Many of you will say, ma'am, now only we have seen top to bottom, lithium will have the smallest size. See, lithium, students, do has the smallest size, but it can be hydrated. It is heavily hydrated. It is heavily hydrated. It is heavily hydrated. And if it is heavily hydrated, then lithium positive ion in aqueous form will have the largest size. It will acquire largest size if it is heavily hydrated. The smallest size will have the largest, size in aqueous medium because it will be heavily hydrated. That means lithium aqueous will be the right answer. Hence, option number D is the right answer. Everybody write it down so that I can move on to the next question now. Shall I? Done, students? Okay. Now comes chloride ion and potassium ions are isoelectronic then. Isoelectronic refers to as the one which has same electrons. So if they have same electrons, then which of the following is right? A, their sizes are small. B, Cl negative ion is bigger than K positive ion. C, K positive ion is relatively bigger. D, their sizes depend upon other cation anions. See, if they have same number of electrons, then you always have to remember anion size will be greater than the cations one. Cations are smaller. So anions are negatively charged. So that means anions are, that means Cl negative is bigger than the K positive one. So B option is going to be the right answer. Let us see the next question. Smallest among these species are very simple. Now only we have seen top to bottom number of shells increases. So the size is going to be increasing, right? If size is increasing, hydrogen will have the least smallest size. So smallest among these species is hydrogen. The next is, it's time for the previous year questions, students. Now we have completed basically our, we have finished our homework session over here. I hope so now your homework queries are clear. Now we are starting with the previous year questions. The very first is, the IUPAC name of an element with atomic number 119 is going to be what? Now see, these are previous yearly asked question for different competitive exams. Starting with 119 atomic number. For 1 we are going to write un. Again for 1 we will write un. For 9 we are going to write E double N. So it is going to be in, yum. So this is going to be the name in, yum. That means, ma'am, option number A is going to be the right answer. Option number A is going to be the right answer. Clear, everybody? Everybody please write it down. Done? Okay, let us see the next question. Next question is, the electronic configuration of an element is this much. What is the atomic number of the element which is just below the above element in the periodic table? See, what are the number of electrons? First of all, see, 1s2, 2s2, 2p6, 3s2, 3p3. That means 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 3 is how much? 12 plus 3 is 15. 12 plus 3 is 15. Yes, everybody. So what do you feel? To which group it would lie? It is 2s2 3p3. 2s2 3p3. Which family? Which family? Nitrogen, phosphorus. Yeah? So over see, nitrogen has an atomic number 7. If you will add 18 to it, it will become 15. P block elements. So phosphorus, nitrogen, phosphorus. Then arsenic, then antimony, and then bismuth. So then you are going to add what? You're going to add what? 18. If you're going to add 18, what you will get? 33. If you're going to add 18, what are you going to get? 33. That means the next element, arsenic, will have an atomic number 33. Simple, easy. Shall I move on to the next question if it is done, students? Yes, everyone. If it is done, can I move on to the next question of yours? Everybody write it down for once. If the atomic number of an element is 33, it will be placed in the periodic table in what? Now only we have seen 33 element is basically, it lies under which period? 33 one. Now only we have seen, no, it is 33 element. It lies under the P block elements. It lies under the group number 15th, right? That means the fifth group. Group number 15th is basically the fifth group. So option number C is the right answer. Clear, everyone? Option number C is the right answer. Fifth group or 15th group? Fifth group or 15th group? Clear? Next is, which of the following oxides is most acidic in nature? Most acidic in nature. Let me tell you, students, BeO is most acidic in nature. Why? Because metallic character, as we move from top to bottom, increases. If metallic character basically increases, that means basic character is increasing, right? So most acidic will be BeO. Clear? Moving on to the next question now. Among the elements, calcium, magnesium, phosphorus and chlorine, the order of increasing atomic radii is. Now this is a kind of a question that is your homework for now. Yes. This is your first homework question for today. Your first homework question, because see, atomic radii hold some variations, some of the exceptions. So I want you all to try by your own as well. So this is first homework question. Among the elements calcium, magnesium, phosphorus and chlorine, the order of increasing atomic radii is what? A option, magnesium have the least, then calcium, chlorine, phosphorus. B is chlorine, phosphorus, magnesium, calcium. C is phosphorus, chlorine, calcium, magnesium. D is calcium, magnesium, phosphorus and chlorine. Moving on to the next question. Which of the following has the largest size? Very simple. Anion will have the largest, then the parent atom, then will be the cation. So anion, that means Na negative, then it will be Na, and at last it will be cation, Na positive. So this is going to be the order. Which has the largest radii? Option number C will have the largest radii. Next, which of the following has maximum electron affinity? Yes, students. Ma'am, we very well know fluorine, chlorine, bromine, iodine, electron affinity basically. When we move down the group, what happens to that? It is going to decrease because size increasing, but there is an exception. Chlorine will have the highest electron affinity. So option number D among the following is going to be the right answer. Yes. So yes, students, here we are going to end our today's class. I hope so your today's class was helpful for you. You were able to solve questions, you were able to understand about chemical bonding. But now in the next lecture, we are going to do a lot of structure-based questions, a lot of structure-based concepts. So be prepared for that session, and yes, do revise your previous chapter because revision is really very essential if you're preparing for any competitive exam. Now students, we shall meet you in the next class. Till then, keep smiling, keep learning. Thank you so much, my dear students. Take care. Bye-bye. Thank you.